Okay, the next talk will be done by Mandi Walls. She is a real IT woman, and very glad to have her here. She will talk about automation with Chef. So give him a warm applause for Mandi. Thank you.
All right. Oh, thanks. So I'm going to talk about actually one of Chef's new projects. So if you're familiar with Chef, you know we've been around about 9 years doing infrastructure automation, systems automation, that kind of stuff. Last year we launched a new project called Habitat, and that's what I'm going to talk about. So I am Mandi Walls. I am the technical community manager for EMEA based in London. So we're here joining you today from there. If you'd like to tweet at me or hit me up on social media, I am LNXCHK. Or you can email me at my Chef address. And if you're interested in this project going forward, when we tweet about it, we use HabitatSH as the hashtag. So there's announcements there about workshops and other projects and things like that will be on that hashtag. So over the years, as Chef has worked with more and more companies, what we have found is similar to the things Chris was talking about in the last talk, is that IT is evolving, and every business is becoming a software business where technology and customer interactions and those sorts of things become more and more important and more digitally driven. Last year at our conference, we had the then CIO of Alaska Airlines, and basically their discussion was about being a software company with airplanes. You think about large capital investment, a lot of money into the airplanes, but they told a story about gaining efficiency using software. And the drive for using their capital more effectively comes out of applying technology smartly to their processes and procedures, and a lot of that comes out of IT. So we're thinking about that. We've been thinking about how large companies are approaching agile, the cloud, immutability, all of these new buzzwords and how all these things fit together. And similar to how the evolution of DevOps happened, we're looking at sort of what's going on next and thinking about different spaces for requirements, different people's requirements, different teams' requirements for how an application runs, gets deployed, gets maintained over its lifetime. Different groups have different requirements, have different things that they're looking at and they're thinking about, whether it's the code itself or fixing bugs or the security of passwords and those sorts of things, or it's how the storage is going to maintain or where the system's even deployed. There's a lot of diverse requirements that go into these application architectures. So we were building down through all of these things with system automation, and a lot of it becomes very complex. And so we pulled out the sort of essential parts and got Habitat. When we think about where we came from, Chef and the initial customers we worked with, we're looking at why anyone actually runs infrastructure. What are you actually doing with it, right? You have a lot of machines, you have some networking gear, maybe there's racks, maybe there's cool pull-out slide drawer things with the pop-up monitors on them that Dell sold with their racks years ago. And we're not running infrastructure just because we can buy cool stuff with blue lights on it. We want to have infrastructure that supports our applications that the business requires, so it helps us maintain our communications with our customers, hopefully makes us money for the business. So sometimes it's fun. We might run infrastructure as part of our business if we're part of a cloud or an MSP. But increasingly, in the future, a lot more things are going into public cloud. I'm not going to necessarily own the gear that my applications are running on. And therefore, we need to think about what happens when I want to just run an application. So we were thinking about this. Last year, we launched Habitat, talking about how we get an idea from the developer and the product managers think about it, and they're like, this would be great, let's try it out, to getting it into production as quickly as possible. There's a lot of other thinking and writing about this. You've got Jez Humble's book on continuous delivery. You had some of the things that Chris was talking about in the last talk about trying to get all the friction out of that system, but still maintain all of the requirements that everyone has. So how do we run stuff? We've been working with large and small businesses for years, trying to figure out the most efficient ways to help them automate all of their systems needs. So some people run things in data centers that they own. Some of them run it on somebody else's data center in the cloud. Maybe they have a hybrid model. Maybe they're using containers, maybe they're not. Maybe they're trying something else that we don't even know about yet. They might be on, if they're on Linux, they have to decide if it's going to be Ubuntu or Red Hat. Maybe they have this policy where if it's not production, it's on CentOS, or there's one other team that wants to run all their stuff on Arch Linux, and you're like, why? What are you thinking? You have all of these additional complexities. We have to figure out what matters. So our goal is to run an application, and we have all this extra baggage that comes along. I have to figure out my operating system, the distribution, the version. There's significant differences between Red Hat 5 and Red Hat 7. What packaging type am I going to use? My language that I'm working in might have a packaging system like Java has war files, Ruby has gems, but then I also have my system packages, RPMs and debs and whatever else. My initialization system, how do I tell operations how to get the process started? Is it systemd? Is it initd? Is it upstart? Is it some other weird thing that we wrote internally to deal with having all these other things? Where does it have to live? Do I have a special place? Is it on a separately configured division on the disk? How do I configure it? Is it just a conf file with some text in it? Is it structured like JSON or YAML? Is it something we came up with internally and we just called it a .dat file, and it's like you figure it out yourself? And then what version of the language runtime? All of these things cascade into decision trees, really, when you're building the application platform. And we found that maintaining these complex environments in Chef made for some really complex recipes and other components to go into the Chef environment. So it isn't really managing complexity. It's adding to it, maybe in a structured way, but not in a way that makes things easier to understand. So we're looking at Habitat. We're trying to take some of the chaos, some of the individuality and snowflakeness out of running applications on traditional infrastructure, with moving towards microservices, a lot more complex distributed services. Taming this chaos is going to be very important because it's hard to rationalize what a massively distributed system looks like, and thinking about how all the things are interconnected and what depends on what else and all of these other components is a lot more difficult than in just a monolithic structure. In Habitat land, the application comes first, and I'll talk more about what that actually means and what that looks like in a minute. What we're seeing is that modern applications are trending toward a couple of things. Immutability has been discussed for the past 18 months, I guess, figuring out how to build something once and deploy it wherever you need it to go, whatever that ends up looking like. Also looking at platform agnosticism, dealing with the differences between what my chosen operating system looks like on one cloud provider versus another cloud provider versus what it looks like on premise. Any given, especially on Linux, any given Linux distribution may have up to 7,500 packages, and any infinite complex combination of all of those, so maintaining a rational way of thinking about them. We also want to reduce that sort of complexity and all of the other things that ship with your application, and think about scalability. What is actually needed to make sure my applications can deal with what I hope to be something very, very popular when I'm actually writing it and deploying it. What Habitat then gets you is a couple of different components. What we're hoping for is a new way sort of thinking about just encapsulating your applications. But along with that, we're giving you some tools. So One of those things is to help you defer decisions to runtime, where I don't have to necessarily know exactly where all of my peers and all of my dependencies live until I'm ready to actually run the system. And outside of containers, some applications are getting better at this anyway. This was sort of a natural progression as people were looking at sort of the build once and run in test environments and run in production environments. We're still seeing folks sort of slipping with that and putting in config files that are special for whatever environment. We want to step back from that and say, this is my one binary, my one artifact, and we want to run it everywhere. We're also providing an environment to do what we're calling Cleanroom Builds. And there's nothing more frustrating than taking your application that you carefully crafted on your dev environment. It has all this list of its dependencies and the libraries that you need, and then packaging it up. Operations deploys it on production, and they're like, dude, we don't have this library in production. Where'd you get this thing? And discovering that it had been added to the dev environment by a coworker months ago and nobody realized it. So we want to care about the things that we need for our applications, and not necessarily the cruft of the other thousands of packages that might live on the systems that we're deploying to. We only want to care about the handful of things that our application needs. We also want to provide a way to do repeatable builds. So the plan files that we'll look at in a minute are fairly simple compared to the layouts for more complex build processes. It tries to take a bit of the abstraction and give it to you in a nice, readable way, but they're also very shareable. So they're not binary. They can go into your GitHub repository, wherever else you're sharing your code, so that you always have it living with the application that you're then going to deploy. The packaging system is distro agnostic. Right now it's 64-bit Linux. We have a beta for Windows, which is pretty awesome as well. It packages it up itself into an artifact called a heart. So it's a habitat artifact. Heart, yay. It also provides you with service runtime and a bit of discovery. So there's a bit of extra stuff that travels along. So you have these extra components for managing the applications right in the artifact. You can either use them or ignore them, depending on what your system already looks like. There's also configuration exposed via the API, so you can see exactly what went into the artifact. So I have my Java build, and I can say this is exactly which components are included in the artifact right from the runtime. I don't have to worry about finding the build system or wherever. It's actually right in the supervisor. Then the packages are all signed by the system. I can share those keys, and my team can create their own signed packages. So we're driving towards what it looks like to build a modern application. We have sort of a microservice architecture maybe that we're targeting. Things are a bit smaller than they may have been traditionally. We start with our depot, where we're keeping our the skeleton for any of our components. We have the outline for how it gets built, what it needs. We have our code somewhere that we can pull in. We take all of these things and mash them up and create our artifact, and then our artifact can go and live wherever it needs to go. So it might be on bare metal. We might still have things that we're running in our own data centers. We might have containers that we're using. We might be pushing things to cloud or just regular virtual machines, depending on how we've structured our architecture. So the Habitat Studio is the main component of the tools that come with Habitat. It is a clean room. So there's a very stripped down version of a Linux distribution called BusyBox that's embedded inside. And there's not much else in there, right? So when you get into the Habitat Studio, none of those accidental dependencies are already living there. It's brand new and fresh for the application that you're building. There's then a set of tools for manipulating and running the artifacts. So you can build them, you can export them, you can run them as they are. So why would we want a studio? So when we're thinking about platform independence, there's a lot of differences between just different types of Linux. If I'm going to build a system and I don't want to have to care if it's going to be on Ubuntu or on Red Hat, I have to step back and say, all right, well, I need these libraries, but if my target is Ubuntu, I need to know that these packages are called blah blah slash dev or whatever. And if it's going to be on Red Hat, it's going to be blah blah slash lib. And there's all this extra information about these components I have to know. And I want to take all that stuff out. So the studio helps us bring in sort of fresh versions of all of those dependencies. So you don't have to assume or hope or then document what's going to go onto the hosts that you're building your packages for. So the plan files are where you start for putting together your builds. They're in Bash. So some things we learned from Chef. Chef, if you're not familiar with it, the user space stuff is written in Ruby, and users write Ruby. And for people who know Ruby or aren't scared of Ruby, that's great. For people who are a little more hesitant on Ruby, that's a real stumbling block. And there can be a bit of a ramp up in learning for just dealing with the syntax and some of the quirks that Ruby has. So we step back to sort of early first principles, right? So there's a lot of stuff that's in Bash. It's on all your platforms. It comes everywhere. So the plans are in Bash. They have some methods in them we'll talk about in a minute. They can be versioned, and then you can share them on the Habitat Depot, which is a centralized location. Share everything so that you can talk about what dependencies you have and share them that way. And then the plans are sort of divided into multiple sections, depending on what your application is going to need. But they're pretty, we hope, self-explanatory. So I have things like the name of my package. I have a bit of a description. I have the version. I have the maintainer, who is me or my team. I have a license, so that when I'm publishing this, people know whether or not they can use it. I have the source. I have dependencies that might be for runtime or build time. I have things like exposing ports and other components like that. There's also methods. Right now we're calling them callbacks. There are shell functions that are executed when you're building. So you have things like do download. Where do I go to get the code for this application? And do unpack. Is there some special way I need to open it up? Or do install. Where's it actually going to live? So things that are kind of familiar if you've been working with like Make or Maven or some of these other build processes. It borrows a lot from that language. There's also some special variables. Because what we're going to build is a self-contained container. It's not going to have a lot of other system locations in it. So there may be some places where I need to figure out where things live because it's not in a standard place or the place that I may be assuming from past builds. So I have the ability to make use of custom variables inside the Habitat plan so I know where things are. So there's things like the cache path, which is where things get downloaded for build. I have maybe the directory name, if it's extracting into a different place. I have the package file name, package version. Some of these things end up getting set manually via the plan file, and others are sort of part of the actual studio environment. And then there's dependencies. This is sort of the whole point that we were trying to get after. I need something. Obviously, I'm working in BusyBox, and it's not going to be there. And I want to remember, how do I get this? I'm not going to be dependent on system packages anymore. I need to pull in where these things can come from. So Habitat has tools for dealing with dependencies. So this is an open source project with an open source community around it. And there's a whole lot of pre-built things that we think are common dependencies for a lot of applications. So you can deal with those via the hab commands. They can talk to the depot and help you with where the packages are and what they're going to provide. So you have two different kinds of dependencies. You have build dependencies that are only in the BusyBox Habitat Studio while you're building your system. Think about the Maven binary, so the actual stuff that runs Maven. I don't need to put that on my production system. I only need it for build time. And then I have my runtime dependencies, that are all my libraries, the things that help me connect to my databases, those components that have to be there for the application to run, so I can keep those separate. So what gets built? This is sort of the weird part. Everything kind of gets built. So you're starting from nowhere in the clean room, and you have no system packages. And how does stuff get there? The dependency layers for Habitat pulls in everything else from the Habitat depot. It builds a lot of stuff from source. So libraries and those sorts of things, you'll see them come down as source files and get built. Obviously, you want to build your own applications from source. If you're building the source code, then they comes in that way. You can decide then if you want upstream binaries or source for things like your runtime. There's a couple different examples for Tomcat. You don't necessarily have to build something as large as that. You can use an upstream binary for your target platform. For commercial off-the-shelf software, we're working through some examples for that using just the binaries and skipping various steps in the build process, so that what you've got is maybe just the unpack or just the install part of those, and not worrying necessarily about getting things built from source. But there are a lot of sort of interesting things that come up when you're dealing with building stuff from source. We had the discussion about packages like 15, 16 years ago. And so it's like, everything has to be a package. I don't care if you don't want to build it, shut up, figure it out. And packages totally won. You install stuff onto Linux via packages. And that, unfortunately, added a bunch of complexity that we're still dealing with. We're still figuring out, oh my God, I have this yum thing, but I have to find this other repository, so I have to add that to my yum config, and then I have to download the cache for it, and all these other things come into the process. We don't want to care about that stuff anymore. I know where the software is, I know how it gets built, I'm going to build it into my artifact that way. Some upstream stuff is kind of hard to build, or it's maybe boring, I will say, to build. And the provider may recommend packages. And in some of these cases, the Habitat community is helping. So I had an early sample application I was working on, and it uses a MySQL database, and I'm like, I am not building MySQL from source. The last time I did that was probably 2002, and it wasn't a good experience then, and I don't want to do it again. So Joshua Timberman on our team helped me out with that. So we do have a Habitat community. There is a lot of folks that are already experimenting with a lot of these more complex components, so that you can ask for help if you're up against something that you're not sure how to build. The next part is the hooks. These come with the app. It tells the application how to get started, because we don't have an init system, right? So how do I actually launch my application? Plus, if there's something that needs to be done before it starts, like pre-populating a database or some other piece of component. So a run hook file looks like a shell script, because it is a shell script, firing up just the essential parts of what my application is going to do. If you still have nightmares about Catalina.sh from earlier versions of Tomcat, because it's like 1,500 lines long, this is sort of the digested version of that, the smallest components that you need. Configuration, we want to provide configuration that can be manipulated at runtime. So take the same artifact and run it in test, and in staging, and in production without touching the artifact. So I'm making runtime changes that are injected, but the built artifact remains the same. These also travel with the app. And there's variable substitution and templating. We use a component called Mustache, which you can read more about online. And it's hopefully pretty easy to read from a human standpoint. I have basically some environment variables that I'm going to manipulate, and these are surfaced by the application. The depot is a centralized place for sharing and working with plan files, has team namespacing. The core plans, so the core is the team name, are those built by our folks, the Habitat team. and that's located as app.habitat.sh. You can kind of go through and search for the things that you want to use and figure out what's there, what's not, and if there's going to be other things that you'll need to build. One caveat, right now you will need internet access for using Habitat. You can build some of your own stuff inside your own network, sort of. When it's all on one machine, there's not a good facility yet for sharing things among machines. And eventually we'll have a private depot server, but we're not sure what that looks like yet. So your build output is a heart. It's a compressed tarball, has some metadata and a signature on it. You can export those to other formats, Docker containers being sort of the most popular one. The heart itself is runnable. You can just execute it because it comes with a runtime. So it includes the management, service discovery, other features. It has a bit of a gossip protocol in it so that if I have 6 web applications, they're all hooked together in a semi-connected mesh. So it's at least a ring, but not a full mesh. So they can talk to each other. They do a leader election. One of them can actually watch the depot for updates, and if an update is published, update itself, and then the rest of the ring can update automatically. So there's a lot of things that are built into that. When I want to run a heart, I can just use the heart executable on my machine. I can pass it options for the configuration on the command line using variables, environment variables to do that. Or I can make a lot of different changes. So the application may be listening on one port. I have my gossip protocol I might need to move if I want to run more than one heart artifact on a machine. So I can move things via the command line options. I can tell it where my peer is. So in this case, I have a Java application. Its peer is a MongoDB database. It's still on localhost, but I'm going to bind it to another supervisor mesh of hosts. So I have sort of a service name there for that database. The supervisor is self-organizing. We can just launch things, and then they'll figure themselves out. As long as they're on the same physical host. There's a couple of other architectures for moving them around. The applications join groups, and they use this gossip protocol to organize. Once the heart is running, you have another interface on a REST API to figure out what's actually in it, what it's doing. It also produces a list of package dependencies. So I can see, well, all right, here's my running containers. I know there's a bug in this version of this library. Which ones do I have to update? You can query your running applications for those bugs. So let's see if we can get this to go. This is 2 components. So there's a MongoDB database running in Docker. So it's built in Habitat, exported to Docker, and then a Java application that's actually going to run in Habitat. So I've cut these down because the whole process takes about 15 minutes. But we'll see how they do. So this is going to start with a Habitat artifact build, and then export it to Docker. Okay. Oh, I missed it. Sorry. Let's go back. There we go. This one. There we go. So have package export Docker, and then the package that I want. It does all of its download. Now it's downloading all of the things that it needed. The rest of the libraries, things like SSL, zlib, GCC, all these components so that it can actually create this MongoDB artifact for me. Now I have it ready to go from Habitat side. I'm pulling in the rest of the things I need for Docker. And now it's going to actually export it to that Docker container. So it's going to build the rootfs and all the extra pieces for the Docker container. So when that's done, what I have is I started out with a plan file, so .sh, a couple of hooks, some config, and I end up with a Docker container that then I can use wherever I need to do. So I'm going to run that just with Docker compose so that it fires up. Did it go? Okay. All right, so now that's part's running. And the last component is the Java application in Habitat. So this is a couple of components that get pulled in. It's a Java application running in Tomcat. So it's pulling in all of those requirements and building the Tomcat pieces and the Java pieces. And at the end, it's actually just going to be a Habitat heart that's going to run natively. So the command that gets used is actually hab start, and then all of these dependencies happen sort of automatically as the process proceeds. So the same sort of thing. I'm downloading all of my requirements and composing them into this artifact. And then eventually it's going to just launch it. So you can see where I have National Parks default is my service name, and it's launching the actual components that it needs to run the Java application. So what comes up then at the end is a National Parks application. So it's a nice Java app with a nice graphical interface that you can see. But you also get then these services exported for over the supervisor REST API. So I can actually see what went into the package that I built, all of its dependencies and all of its configuration. So that's pretty much it. You can join us on Slack. That's where this community meets. We have lots of folks here in European time zones that are using Habitat right now. So if you have questions or problems or things that you want to look at or get help with, we have folks in your time zone to help out with that. There's also online tutorials where you don't necessarily have to build anything yourself. It works right in the browser. So you can see how the tools interact, what the command lines are, and how they work without installing it all on your machine. The project itself is on GitHub. And actually, the demo for this talk is in my GitHub. If you're familiar with Vagrant, it's really, and Test Kitchen, they're the only things that outside of this repo that it needs. You can download that, launch the Vagrant guest on your system, and it will install Habitat and Docker, and you can actually run this demo to see how it works. If you are interested in getting started with Habitat and you have a project and you want to share your story, we're looking for folks who are early adopters and enthusiastic on trying it out. So you can let us know what you're doing, and we'll send you some Habitat swag. Finally, our conference is in Austin next month. We'd love to see more folks from the region. If you're able to join us, we have certification and training and lots of things going on there, but there'll also be lots of folks talking about Habitat and the things that we want to do with it. So I think we have a couple minutes for questions before we break for the next thing.
We have some minutes for questions. Anyone has some questions for Mandi?
Can you elaborate what the commercial part of it is, or is there none?
No commercial part right now.
Even the depot is also private available?
The depot's open on the internet, so
Yeah, but can I have private shares there?
Not yet.
Ah, okay.
No, we're still working on that. Like everybody we talk to, that's the first thing they ask us for, so that'll be coming probably later this year.
But this maybe will be commercial then?
Not right away, I don't think. We'll see. It hasn't been discussed as a commercial option. So yeah, it's all free, open source.
Any other questions? No? Thank you very much, Mandi.